Right, thank you. So I came across Redis at work, and I was using it to store values for Python in a key value store, and I was enthusing about it to my colleagues, and they said, oh, you should do a talk about that. So you're stuck with the result. So Redis is essentially a key value store. That's one of the family of NoSQL entities. You don't need to read all of this. This is both way more stuff than I'm going to talk about and also doesn't actually describe everything Redis does. So why I like Redis is it's got an elegant design. It keeps letting me do what I want. It's got excellent documentation. It's got good Python tooling. And it fills an interesting niche. And that niche is I want to be able to store Python data structures persistently somewhere else and then get them back again. So the analogy I would rather strainedly use here is we've got a TARDIS. We can move information through time, so a program can save its information and retrieve it later. We can move information through space. A program or a process or a thread or whatever can pass information to another program, process, or thread. And as in Doctor Who, there's no problem with language. So there are bindings for Redis for all sorts of programming languages. So if I want my Python program to talk to my Rust program, I can do it through Redis. So the Redis documentation says Redis is not a plain key value store. It's actually a data structure server supporting different kinds of values. And this is key. Luckily, a lot of those values map into the common usage patterns that we actually have in Python. So we can make a connection to a Redis server. So this would normally be running on another machine, but here it's running on my local host. And this is using the Redis command line tool, which is really rather nice. So for instance, if I start typing set, you can see the grey blob there, that's how much I've typed. It's already giving me hints about what I might type next, and that's consistent throughout the command line. That helps immensely. You can obviously say we're going to set a key and a value. It's got other odds and ends that we might set there. You have to go and look up to see what those mean, but once you come across them, that helps remind you what it is you can actually type. So for instance, ex seconds says, I want to set this key, and it will expire, it will go away in so many seconds, so it will only last for a while. There's also excellent help within the command lines tool. So here we're asking about help for hash commands. It goes on beyond the bottom of the screen. I don't know how well the yellow shows up there. So this is giving me a brief summary of what you can do and what version of Redis you have to be using to use it. Of course, we're in Python, so we should be using Python. So this is the redis-py library. I have to look up the number here. So the Redis clients page, when I was doing these notes, listed clients for 50 different programming languages or infrastructures, and 14 individual links just for Python. So redis-py, it says, is mature and supported, currently the way to go for Python. And luckily, my colleagues at work had decided, indeed, to use redis-py, so that's all good. We're using strict Redis here. Historically, the original version of Redis had a class called Redis, and some of its arguments weren't the same way around as in the normal Redis documentation, so you had to think about how to use it. Strict Redis mostly differs in just some of the arguments to some of its methods being in a different order. So Redis is legacy, you're not meant to use it. So here we're explicitly connecting to the local host. We could also specify which Redis server on that host we wanted, and also which backing database we were using. I'm not going to talk about either of those capabilities, because that's getting way too complicated for me. So as I say, it's a key value store, so we've got keys and values. So keys, Redis calls them binary say strings. They're identical to what we call a binary string. They recommend that you not have a key that's more than 512 megabytes long. They actually say, 1024 bytes is a bit long for a key, and we recommend shorter than that. They do also then say, don't make them too short. So give structure to a key, give it some interest. And you can see here that they're suggesting namespace name. Actually, they tend to say server name with a colon in between. So they like colon-separated names for their keys. Because it's byte strings, it doesn't have to just be ordinary plain text in there, and we'll come back to this later. You can put, for instance, JSON in your byte string. We'll also, because it's byte string, Redis doesn't address encoding. We'll come back to that a bit later as well. You have to worry about encoding yourself, which I think is perfectly reasonable. So looking at an example, here at the top, we set my key to have the value value. It's not very imaginative. We get true back, telling us that worked. We can then delete my key, and we get 1 back saying that worked, and the key used to exist and is now gone. If we then ask if it exists, it doesn't. So we can now delete this key that doesn't exist, and we get 0 back, which is saying you successfully deleted this key that doesn't exist. And then you check it doesn't exist. This feels to me common with the way that Python handles emptiness. So empty means false in Python very often. In Redis, if you assign to something that doesn't exist, it will magically spring into existence ready to receive your thing. If you delete something, it will magically disappear. This is practicality beats purity sort of approach I rather like. So there are lots of other things you can do with keys which aren't on this page. You can dump and restore the keys. You can produce a pickle essentially of a key. It's not a Python pickle, but it's equivalent. You can find out what keys there are. You can iterate over them. You can migrate a key and its value from one Redis server to another. So this is, again, the TARDIS approach. You can sort the values of keys. You can find out what type the data is in a key. So we're talking about values. So values can be, as you might expect, you can have a byte string again. A binary safe key. You can have lists and sets, sorted sets, which I'll come to later, hashes, which are dictionaries again. You can only go 1 level down. So your key value, the value can be a dictionary, but you can't have the value of that be a dictionary. You can't recurse downwards. We can have bit arrays, which is bitmaps, geospatial values, so you can put geographical coordinates in and do nearest type queries, and hyperlog logs, which I don't understand, but apparently make people who are into logs really happy. I'm not going to talk about those last 3 much, because they're getting a bit abstruse. And there are some other odd things as well, I think. So string values, binary safe strings as before, so again, no particular limit on size realistically. It's not uncommon to store something like JSON in them. Encoding is out-of-band information, so we can set my string to have some text in it. We get true back saying I succeeded. We can get the value back. I can ask how long the value in that key is. I can ask for the 5th through last character. -1 here means last character. You can't do -2, but at least you can do -1, so it feels a bit friendly. All sorts of other things you can do that you might expect. We've got append operators. You can set a substring, so I can change the middle characters. You can get a value as it is and then set it to a new value in one atomic operation. So you can say, tell me what it was, and set it to this as one immutable operation. So that can be quite useful. And you've got key operations that let you set and get multiple values at a time, and also the ability to set something only if it doesn't exist. So you can say, I don't want to overwrite something, only set it if it doesn't exist. Interestingly, we can increment and decrement strings if they contain integers, or indeed floating point numbers. So here we've set my number to be 1. We can get it back, it's 1. We can increment it, and now it's 2. That's an atomic increment. So if I increment that key, and another user of the same Redis server increments that key, it will go up to 1, and then it will go up to 2. There will be no intermediate stage where we're not sure what value it is. That's really a nice thing, this atomicity. And atomicity is a thing throughout all of Redis's commands. It does that technically because each server is a single serial process. There's no parallelism going on. So this gives us counters and semaphores. That's quite sweet. I had a program where I was using Redis to do something, and I found I needed a semaphore. So I could have gone and got Python semaphore library out and played with that. But I didn't need to. I'd already got Redis. I just added another key value that was a set that I was using as semaphore. Interestingly, you can increment by floating point numbers as well. You don't need to decrement floating point numbers because you can increment by negative floating point numbers. I have no idea why you'd want to do that, but there we go. The bitmap operators that I talked about before also count as this sort of operator, but they're a bit complicated to use, and I'm not going to go into those. So I said encoding was up to us. You may have noticed that I was giving byte strings mostly, but a couple of times I've given an ordinary string, and for one I gave an integer. Everything is under the hood is a byte string. So if you give redis.py a byte string, it says, yeah, that's okay, I know what that is. If you give it something that isn't a string, it first converts it to a string. So if it's an integer, it'll strut it. If it's a float, it'll wrapper it. and turn the result into Latin 1. And for anything else, it will call str on it. And then it will turn that string into UTF-8 with strict encoder errors. And the strict encoder errors means that if it's not sure what to do, it will get an exception. It won't try and guess, which is exactly what you want. So in general, if you remember to put the B in front of your strings, you'll be OK. But you'll probably be OK if you don't as well, if you just give it an ordinary string or something else that should be a string. I recommend putting a B string in, a byte string in, and I've tried to do that in all my examples. It's possible I've missed one further on. You don't have to shout if I've done that, unless you think it's not. And all of these examples are from real code, so they all should work. So next we've got list values. These are actually closer to a Python deck in that I can left push. So I've left pushed 3, 2, and 1. I've got 3 items. I can right push 4. That gives me 4 items. If I then get the range of values from 0 to -1, that's from the beginning to the very end, you can see that the ordering is what you would expect given that as left and right pushing. So left push, given more than one value, does left push the first, left push the second, left push the third. I can pop an element. I can actually pop a random element, but I don't know why I would want to do that, from either end, which leaves me back, my list has now just the middle bits. So you can do all the other things you'd expect to be able to do with lists. You can set them by index. You can get things by index. You can push and pop. You can push and on either end only if the list exists. So that would stop you being able to push to a list that doesn't exist if you didn't want that. You can find the length of a list. You can insert things by index. You can remove the one or more elements with a particular value. And you can trim a list down to just the specific range of indices. So if I wanted to take a list of 4 items and just trim it down to the 2 middle ones, that's easy to do. And there are blocking variants of the pop operations. So when I do pop, left pop and right pop, I can say I want that to wait until there's something to pop. So if it's an empty list, it will block, and I can specify timeout. If I don't specify timeout, it'll wait forever until someone pushes something into the list for me to pop out. Which leads to my favorite Redis instruction, which is BRPOPLPUSH. So this is a blocking right pop, left push. So I pull a value off the tail of source, push it on the head of destination, and give it back to me. That last was a really nice thing, because I found this instruction because I wanted a circular list, essentially, and I was thinking, oh, wouldn't it be nice if it told me what value it had been moved? Because if I rotate the value and then want to delete it, if I just delete the 0th value, someone might have changed the list while I was asking for that, so it won't be the 0th value anymore. But because it returns it to me, I know which value to say to rem, which particular value to remove. So you can block, or you can wait for a timeout. Pardon?
Source and dest are keys.
So source and destination are keys, yes. Sorry, that wasn't clear. So in the example, so we're left pushing to something, a key I've called my deck. We can see that inside that I've got these values. If I do BRPOPLPUSH from my deck to my deck, so my source and destination are the same key, the new value I've got, the value 1, I'm told the value 1 is what's moved, and you can now see it's been moved to the other end. So they suggest using this for a circular list or for, they call it a reliable queue. I was just very pleased that this is an atomic operation, does exactly what I needed. The documentation told me exactly what it did, and the one thing I thought I might want extra was a thing they'd already thought of. And that's one of the reasons I like Redis is that I kept hitting this. I'd like an instruction that does that. There it is. I read the documentation. It tells me that it does exactly the thing I'd like an instruction like that to do. So they've play tested this very hard to make sure it does the common use cases. Set values. We know what sets are, and they behave like sets. So we can add A, B, and C to the set 1. We can add X, B, and Z to set 2. We can find the difference between those two sets, and that gives us back the difference. We can intersect the two sets and store them into a third set, and that means that set 3 has now got just the intersection in. That's very useful. That saves you a round trip. And we've got the normal things we'd expect. We've got union and union store. We've got scard, which I think stands for cardinality to get the size. I'd have called it slen, but then that's just me. We can remove one or more members, as we'd expect. We can ask if a value is a member. We can pop a random member. I'm not sure I'd want to do that, but hey, we can move a member from one set to another. So this is, again, the idea of moving values around. And we can iterate over the members. Sorted sets are something I'd never come across before, and they're very useful. So here we've got a key, and then each element that names is a value and a score. So the value we know about, and a score is a floating point number. And the values still need to be unique, the scores don't. So a typical use of a score might be a Unix timestamp. And I can then pop or whatever elements by their score. So it makes it very easy to store a set of values and the time I put them in the set, and then say anything older than a particular time, in other words, from negative infinity to this particular timestamp, removed from the set. And you've got all the other operations you might expect to have, given it's a set and this thing that's got a list of values. I've now lost my place in my crib sheet. I apologize for this. It's because there's lots of bits, the crib sheet is useful. So here's an example. We put 0A into Z set. It tells us we put one thing in. We add 1B. We can then find what are the values in there. We can then say what are the values in there with their scores for just the last element. This is one of the few cases where the Python method is not the same necessarily as the instruction that you would use at the Redis CLI. There are two instructions, zrange and zrange with score. It actually feels better in Python to have one zrange where with score is an optional argument. We can have dictionaries inside our keys. The terminology gets a bit confusing because we have the outer key and then we have a field and a value. I tend to find that confusing, but yeah, okay. And you can increment and decrement those values just like you could if they were a normal value. So your 2-level down value can be incremented or decremented. And all the normal operations apply to the value. And here we're setting my dict to have a key and a value and another key and a value, and we can get the internal key, the field, and we can ask for a field that doesn't exist. We'll get none back. It doesn't show very well at the prompt. We can ask for the keys. We can get what we would call in Python the items, the keys and the values. You can find out if a given field exists. You can get and set multiple ones for convenience. You can scan over them. All the normal operations you'd expect with dictionaries. I have one grumble about redis-py. So the ping operation for Redis CLI, if you give it ping, it gives you back pong. If you give it hello world, it gives you back hello world. If you use the Redis Python library, if you say ping, it gives you back true. If you say ping of hello world, it says, I don't understand how to do that. This was actually something that my first encounter with Redis was trying to debug why we weren't talking to our Redis server. And I hit this, so I was reading the documentation. It says, use the Redis documentation for how to use the library. And I got stuck on this, and I had to read the source code. I think that the fact that this tiny, tiny, tiny niggle is the bad thing I have to say about this library should tell you something about the quality of the library and the server that I'm talking to. So this is a terribly small thing, I mean ping. And if I cared, I could put a pull request. I probably wouldn't because it would be backward incompatible. So there we go. That's my grumble. So the online documentation, I like documentation. I was at Write the Docs last week. Documentation is cool. The Redis documentation is excellent. So it's mostly, there isn't a start here, read all through it technical manual. It's organized as a set of articles introducing useful parts. So there's an article on Introduction to Redis Data Types, which does this talk, but more examples and better spoken. If we go and look at the web page for the commands overview, this expands out below and sideways. And for every command, there's the name of the command, the summary of what you can type it, and a brief description of it. Click on that, you go to the command. You can filter that page on the types of commands, so I can say I just want to see the hash commands. If we actually do go to a command, for instance append, it tells you Again, a summary of how to use it, when it was introduced, what its properties are and things you might want to know about it, what it's for, its return value, and then below that it goes into use cases, what you might use it for, examples of how you might use it. And then on the right, where we can't see it, it has other related commands that you might want to look at because you're using this command, or because you came to the wrong command because you weren't sure where you were going. I shouldn't do a talk without unit testing. There's a very nice library called FakeRedis, which provides a fake strict redis. So this is using it. The singleton, it's possible, if I say singleton equals true, then all of the fake strict redis instances, of which I have said singleton should be true, will share their memory. So I can have pretending to talk to the same server. In all the unit tests I've done, we don't want that. We just want to say this is a unique fake Redis. And so I can just talk to it with normal commands, and it will work as you might expect. And lastly, almost, recently I was playing with asyncio, and there's a library called aioredis, which looks just like the normal Redis library, but you put awaits in all the right places. So this is an example of their web page. It's really easy to use. Again, we're talking to a remote host. We await setting instead of just setting. I apologize, I forgot to change Redis into something else because I don't like using Redis as a variable. It's confusing. And this example will print value, as you might expect. There's nothing surprising there at all, which is really good. Of course, we want to be able to unit test async aioredis. There isn't a good unit test library already written for FakeRedis. There are, however, unit test libraries with a liberal license for other Redis libraries. And if you look at them, all they're doing is wrapping the original library in an appropriate manner. So it's very easy to create my own, just enough async Redis, and just put in the calls I actually need. Only with doc strings, please, because document your code. Since you're typically only like to be using half a dozen instructions, that's not a large amount of work to do. If you find yourself doing a lot more than that, you probably should open source it, and then I can use it. And so this is the asyncio version of our earlier test. It's very similar. I'm using PyTest, so I can PyTest mark asyncio, which tells PyTest this is an asyncio unit test. The event loop fixture that I'm passing in there gives me an asyncio event loop already set up just for this test. So I don't need to do anything here. So this is a very simple extension of the previous unit test with the weights sprinkled into it where you might expect. There's a few other things that, have I just got time? Just about. So as I said, the Redis server is single-threaded. That means that atomicity is easy. It means you've not got more than one access to that particular server's data at any one time. That's important. There's a rather nice pub-sub broadcast messaging system, which I've not played with, but looks really well done. I like pub-sub messaging. If you wish, there are transactions. It's also programmed in Lua, and they don't assume that you know Lua, so the documentation reminds you that Lua arrays start at 1 and things like that, and they've got examples. That allows you to do other things where you don't want to quite use a transaction, but you want to bind several commands together. The command protocol that the client talks to the server and back is documented. And if you want to do bulk uploads, they actually suggest that you create the protocol by hand for the bulk upload and then pipe it through the CLI so that it gets sent as an official upload all in one chunk. So you can do very big uploads without having to send lots of commands. As I said, geospatial values, I used to do work in mapping, so I think that's interesting. And they're just working on a thing called streams, which, so far as I understand it, is meant to attack we have very large amounts of log data that we'd like to introspect and search through in real time. And this is going to be their solution for that. And that's coming out in the next release of Redis. And that's it. Slides are on the internet. This is a small subset of what this thing can do, but I found it very useful for myself. I think it's a sort of thing that's worth having in your back pocket to play with when you're doing your own projects. It just gives you that extra easy way of doing persistence and so on. Thank you.
I'm afraid we're almost out of time, so I think it's probably best if...
I think it's simplest. Yeah, feel free to talk to me afterwards. I won't necessarily know any answers because you've had all my knowledge. The documentation is very good, though, and exploring, and there's a lot of information on the internet about how to use this stuff. So.
Wonderful, thank you. Let's thank Tony once again. Thank you.